Okay, hello everyone. So today we're going to look at going to start chapter 7, and chapter 7 is actually a continuation of chapter 6, where we have learned previously sine rule, cosine rule, and the area formula for non-right angled triangles. So pretty much now we can settle lengths and lengths and areas for pretty much any triangle. So if we have right angled triangles, we can always use SOHCAHTOA. We can always use area is half base height. For non-right angled triangles, we can use the rest, sine rule, cosine rule, and the area formula. So pretty much we built a list of weapons for us to tackle the many things that we come. So in this chapter, we are going to explore the application part where it's going to be very enriching and it's going to be very interesting, and it will be very fun to use what that we've learned to tackle real life problems. Okay, so the very first what do you call this, the very first kind of problems that we're going to look at is this problem of angle of elevation versus angle of depression. So before we start, let us appreciate these two memes over here. Okay, so for angle of elevation, we refer to the angle as we look upwards. Okay, so an angle of depression would be the angle as we look downwards. Okay, so over here, okay, let me move these two memes away and let me like put them here for safekeeping. Okay, so imagine, okay, so our eyesight is very important. Okay, so let me draw an eye. Let me draw this over here. So our eyesight would be extremely important over here. So I'm going to call this the equilibrium line or the reference line. Okay, so reference line. Okay, so this reference line is going to be really important for us. So let's say if our line of sight is upwards, if you are going to look upwards, okay, this angle over here, that the angle that goes upwards, this angle over here is what we call the angle of elevation, because we need to elevate our eyesight. Okay, so this angle is called angle of elevation. Okay, similarly, if we were to look downwards, okay, if we were to look downwards, okay, so physics students, don't kill me, I'm just up and down. Okay, so as we look downwards, okay, this angle over here is going to be angle of depression. Okay, so it's not really about how depressed you are and then how you suffer with mental health. No, it's not like that. Okay, it's mainly of the eyesight, eye level, how much degrees upwards, how much degrees downward. Okay, so with this, right, we actually have we can make use of one very interesting property, which is, let's say if we have a building over here, we can make use of this building and we can actually make use of this angle over here. And this angle, because the horizontal lengths are parallel, we can actually make use of alternate angles over here. Okay, so over here I'm going to put in a note over here. We can use alternate angles here. Okay, so very perfect for this use over here. Okay, so let's try to take a look at the questions now. Okay, so we have practice now 1, and practice now 1 tells us that the angle of elevation of the top of an office of height 43 meters from a point on level ground. So always make sure to read all these directional instructions, because it's going to give us the position. Okay, so we are over here, we are on ground. Okay, and this is actually our line of sight. So the angle of elevation from ground, so this direction, is going to give me 34 degrees. Okay, so the tower is 34 degrees. The tower is 43 degrees. So find the distance of the point. So I'm going to let this be D, distance of the point on the ground from the foot of the tower. Okay, so this is a diagram I have. This is a question I have. Let's try to tackle. So this forms a right angled triangle. Okay, so do we need sine rule? Do we need cosine rule? We can, but it's too much. Okay, so let's make use of SOHCAHTOA. So we have 34 degrees over here, right? You notice 34 degrees over here, and at the same time, this is the opposite of the 34 degrees. This is the adjacent of the 34 degrees. So which ratio are we going to use? Sine, cosine, or tangent? We are going to go for tangent. So tangent theta, or more like tangent 34 degrees, is going to give us opposite 43 over hypotenuse, over the adjacent D. Okay, so I'm looking for D. So what I can do is make use of a little bit of algebra to swap these two locations. So I'm going to get D is equals to 43 over tangent of 34. So 43 over tangent of 34. Make sure your calculator is in a correct mode before you start. So this is going to give me 63.8 meters. Okay, and this is in 3 significant figures over here. Okay, so there we go. This is our first question, question 1. Okay, so now over here we have a question 2. We have a lighthouse TL, a height of 50 meters. So we have the angles of elevation to the top of the lighthouse, from boat A, boat B. Okay, so you see, so from A, from B, okay, so this angle of elevation, okay, and this angle of elevation. So we have two angles of elevation. So let's draw in. So this is going to be 48 degrees over here, right, from A, and this is going to be 38 degrees from B. Okay, so let me just draw this 38 degrees from B. Okay, so we are going to look for the distance between boats A and B. So we're going to look for AB, right? And take note, because we're looking at lighthouse and we're looking at towers and so on, the triangles that we're going to look at are right angled triangles. Okay, we're going to look at right angled triangles over here. So let me draw out this one over here. So this one to this point, right, like this. Okay, right angled triangles. Okay, so we have to be very aware of this one, right angled triangles. Okay, so let us try to look for AB then. Okay, so the first thing to take note is we can extract out two separate triangles from this question. Okay, so let me draw out two nice right angle triangles over here. Okay, the first one is, this is going to be 50. This is going to be LA. And LA, and this angle is going to be 48 degrees over here. Right? Now, and then I have a second right angled triangle that I can plug off, which is this one over here. Oh, it doesn't work. Okay, so same thing, this is going to give me 50, right? And this is going to be LB, and this is going to be 38 degrees. Do you see this? Okay, so I'm going to look for LA, I'm going to look for LB. So that's my procedure. Okay, and what I'm going to do is AB would be just LB, the longer one, minus LA, the shorter one, and that will give me AB. Okay, so let us use this, let us form the few equations over here. So firstly, let's start with tangent 48. So tangent 48 is opposite 50, and the one that we want is going to be adjacent, so it's going to give me LA. Okay, swapping positions over here, so LA would give me 50 divided by tangent 48. So I'm not going to evaluate first because I want my answers to be as accurate as possible. Okay, next I'm going to do tangent 38 degrees. Same process, it will be 50 over what you call this, LB. Okay, so swapping the positions of tangent and LB, so LB will be equals to 50 over tangent 38. Okay, so what is left now is I'm going to look for the distance AB. So the distance AB now is going to be equals to LB minus LA, right? LB minus LA. So what is LB? LB would be 50 over tangent 38, and LA would be 50 over tangent of 48 degrees. Okay, so with this one over here, we can actually make use of our calculators to find. So 50 over tangent 38 minus 50 over tangent 48, and this in 3SF is going to give me 19.0 meters in 3SF. Okay, so there we go. So question 2, right, something like this over here. Okay, so the thing is that over here for LA and LB, so for these two parts over here, I did not evaluate them. I did not find the answer for LA and LB. I kept the original value so that at the end of the day I get a more accurate value for my AB. Now let's say if you were to evaluate LA and LB, you need to give a little bit more significant figures. So the option over here is to give maybe 5 SF or 6 SF. Okay, 5 to 6 SF. Okay, so that your answers will be quite accurate. Okay, so there goes question 2. Okay, so let's now turn our attention to practice now 2, page 39. And over here we have a Singapore flyer, which is an iconic giant observation built on top of a terminal building. The diameter of the wheel is 150 meters and the highest point is 165 above the ground. So from point A at the top of the wheel, right, Cheryl observes that the angle of depression to a sports car C on the ground is 25 degrees. So from the top, so you see the direction is quite important. So from the top, right, so this angle of depression over here, right? So over here, this angle downwards is given as 25 degrees. So we need to find the distance of sports car. So for this one over here, I want you to pay attention, right? Because especially for angles of depression, we must always start from the top. And as you can see this actually forms a parallel line. And because of this, we have a set of alternate angles over here. Do you see? So we have a set of alternate angles over here. So this means this angle over here would also be 25 degrees. Okay, so now knowing the fact that this is 25 degrees, so let us try to find the BC, alright? Distance of a sports car from point B, which is BC. Okay, so over here, let's observe, we actually have a right angle triangle over here. Do you see this? We have a right angled triangle over here. So 165 and 25, alright? So it will be good to always recognize where is our right angled triangle. Okay, so let me draw out this one over here so that I can model this well. Okay, so that I'm free from all the other distractions. So this is 165, this is 25. Right, degree, and I'm looking for BC, right? So like this over here. Okay, so 25 opposite 165, BC is adjacent, so tangent of 25. So tangent 25 is going to be opposite over adjacent BC, right? So multiply BC up, divide by tangent 25. I'm going to get BC is equals to 165 divided by tangent 25. Okay, tangent 25. So 165 divided by this will give me 353.84. So this is actually 354 meters to 3 significant figures. Okay, like that. Okay, so this is number 1. Let's take a look at number 2, the angle of depression from the center of the wheel to the sports car C. So the right angle triangle that we are looking for is from the center of this one. We're going to look at this particular right angle triangle. Okay, so over here. Okay, so let me extract this out over here and let us draw another right angle triangle. Okay, so over here, the angle of depression. Okay, so the angle of depression will be always from the top, and it will be looking down, and I'm looking for this angle of depression theta over here. Okay, and because this is alternate angle, okay, I'm gonna put my angle over here as well. Okay, so angle of depression, I'm going to put it over there as well. Okay, now next, now now I have BC. BC is going to be 353.8436. Okay, just in case, 8436. Okay, and I will need the height to the center of the thing, right? So the thing is that we go back to this one over here, from the middle point to the bottom point. Okay, so we have a few points over here. So on the ground level, so this distance over here is going to be 15 meters. Agree? Right? So we have 165 minus 150, we have the 15 meters over there. This distance over here would be 150 divided by 2. So this would be 75 meters. Agree? So that whole thing together is going to be 75 plus 15. So this is going to be 90. Okay, it's going to be 90. Okay, so let's try to link angle theta with 90 and that. So at angle theta, opposite adjacent. So I'm going to use tangent of theta. Okay, or more like I let theta be the angle of depression. Okay, so theta of this thing would be equals to opposite over adjacent. Okay, so 353.8436, like this. Okay, so theta is going to be tangent inverse of this weird chunk over here. Okay, and this is going to give me a number. So the angle is going to be 14 point, okay, 14.3 degree. And then in degrees, usually we leave it to 1 decimal place, like this. Okay, so this is how we do questions involving angle of depressions. Okay, so mainly we are looking at tangents, right? Because right angle triangle, opposite the height, adjacent will be the length from our reference point. Okay, so this would be question 1 from practice now 2. And over here, we're going to look at question 2 from practice now 2. Okay, from the same page. Okay, so we have the angles of different page. Okay, so we have the angles of depression from the top of a cliff, 52 meters high. Okay, from the top, right, to A, right, from the top to A, from the top to B, right? So this angle over here is 36. So means this one to A is going to be 36. Okay, and this one over here to B is going to be 24. Now this angle is 24 degrees. Okay, so calculate the distance between the two ships. So what we can do is that we can extract the right angle triangles out so that we are able to work with it a bit better. Okay, so yeah, this is my very failed attempt on drawing like this. Okay, so knowing that they are angles of elevation and depression, knowing that they are angles of depression, we already have this alternate angle over here, correct? So this angle is going to be 24 degrees, right? This angle over here is going to be 36 degrees. Okay, I'm going to let the bottom of the cliff be C. Okay, and this will help me very much to label stuff. Okay, so I have a C to A, I have a C to B. Okay, so in order to look for the distance between two ships, I'm going to look at CB minus CA. Okay, so AB will be equals to the long one minus the short one over there. So over here I have a 52. I have 52. I can set up my angles over here, 36 degrees. and I have a 24 degree over here. So it's very important once again to take note of, like, to try to identify the right angled triangle that you're working on. So calculate the distance between two ships. So over here I'm going to look for AC first. So tangent of 36 is going to be opposite over adjacent. Okay, so AC, when you multiply up, it will be 52, whole thing divided by tangent 36, and I'm going to leave it there first. Okay, next one over here is tangent 24. Tangent 24 would be equals to 52 as well, divided by BC. Okay, so we reshuffle the position of BC. So I'm going to have 52 over tangent of 24. Okay, and this would be BC, and I'm going to leave it there. Okay, next, the distance between the two ships. Okay, so the distance between the two ships is given by AB, and it's going to be AC, sorry, the long one, BC first, right? Long one is BC. Okay, the long one minus the short one, 52 over tangent 36. Okay, so the thing is that we cannot add up the 24 and 36. You have to do it separately because tangent is a bit off. So we have a 52 over tangent 24 minus a 52 over tangent 36. This will give us a 45.2, okay, meters, and this is in 3SF, like that. Okay, so that's about it, I guess. That's about it. So in order to look for the difference in distance, what I may suggest is to not purposely force out the non-right angle triangle. Like you would have gotten like 12 and then a 24 and then 130, 180 minus those two. Don't do that kind of thing. Okay, so what we should do instead is to be a bit more prudent with our steps, make use of right angle triangles because they are the easier things to find. Okay, so this ends our very first part of the application of trigo. We end off with angle of elevation and depression. Next up, we're going to look at bearings. Okay, so stay tuned and we'll enter bearings soon enough. Okay, so that's all. Bye bye.